Okay, now I'm going to teach you exponent property rules. So when you have the same base, so these are both c's, and that means multiplication when they're side by side. So we have c to the negative 2 times c to the 7th. You can simplify this by adding the exponents. So the rule for multiplication of exponents with the same base is that you add the exponents. So you say negative 2 plus 7, and that becomes c to the 5th when you simplify it. Okay, so you add the exponents when you're multiplying exponents with the same base. For another example, if we have b to the negative 2 times b to the 4th times b, so they all are b, so they all have the same base, and we'll multiply them. So we do the exponent property of adding the exponents. So you say negative 2 plus 4, which is 2, and then this exponent is 1, so it's understood as 1. So negative 2 plus 4 is 2, and then 2 plus 1 is 3. So the simplified answer would be b to the 3rd. And then if coefficients start playing or start in the mix, the first thing you want to do is sorry, that was t to the negative 5, is to actually simplify if there's multiplication in between. Here, you can either simplify the negative exponents first, or you can just multiply them and do the exponent rule. It doesn't matter, I'll do both ways. So 5 times 2 is 10, and then negative 2 plus negative 5 is negative 7. Then I need to simplify the t to the negative 7. Well, the 10 stays on top, but t to the 7th goes on bottom. Okay, now let's do where I simplify the negative exponents first. So 5 times 2 stays on top, and then we have t to the negative 2 times t to the negative 5 whoops. Okay, so now let's do it the other way where I simplify the negative exponents first. So we have 5 times 2 that stays on top, and then the t to the negative 2, once it goes on bottom, is just t squared, times t to the negative 5, once it goes on bottom, it's just t to the 5th, and then we can simplify it. We'll still get the same answer, 10 over t to the 7th, because that's a t. T to the 7th because 2 plus 5 is 7. And remember, when multiplying with the same base, we add the exponents. Okay, so here we're going to, so if you notice, there's only one with the same base, x and x. This y we can't simplify because there's no other y's. So we can combine these two right now with the x's. So 5 times 3 is 15. And then we have x to the 7th power times 3y to the 6th. And we got 7 because 5 plus 2 is 7. Now in this case, we can combine these. We can't combine the variables, but we can multiply 15 times 3, which is 45. And then we have x to the 7, y to the 6. So this would be simplified. The next exponent property law that I'm going to show you is when you have a power raised to another power. So c to the 5th raised to the power of 2. With these exponents, you actually multiply them. So when you have a power raised to another power, you would multiply those exponents. C to 5 times 2 is c to the 10th. Okay, so that's simplified, c to the 10th. So you multiply when you have a power raised to another power. So it gets a little tricky when you have something like this. And then, so it gets a little tricky when you have t to the squared raised to the negative 2 or t to the squared raised to the negative 5. You can actually simplify the negative exponents if you want to first, but in this case, I actually think don't simplify the negative exponents yet. Always simplify the exponent property law first before you do the negative exponents. So here, a power raised to another power, you multiply them. So 2 times negative 2 is a negative 4, times t to the 2 to the negative 5 is negative 10. We still have an exponent property law where if it's multiplying by the same base, we add the exponents. So t to the negative 14, because negative 4 plus negative 10 is negative 14. And then I can simplify the negative exponent. So then I can do 1 over t to the 14 because it is a negative exponent, so I put it down on bottom. That's the easiest way to solve these problems is, again, when you have an exponent property law first, simplify the exponent property law, and then you can simplify the negative exponent. Okay, with this one, we're going to simplify the exponent property law first when we have a power raised to another power. But in this case, we have more than one item, one term, in the parentheses. So you kind of have to use distributive. You have to distribute this negative 3 to everything in the parentheses. So you have to distribute it to the 2, so it'd be 2 to the negative third power. And then you also have to distribute it to the y, so it'd be y to the fourth time to the negative third power. And the reason why it's 2 to the negative third power is because there's a 1 right here, and 1 times negative 3 is negative 3 because it's a power raised to another power, so you would multiply it. So I'm going to simplify it even more. 2 to the negative 3 times y to 4 times the negative 3 is negative 12 because it's a power raised to another power, so we multiply. Now I'm going to simplify my negative exponents. So it'd be 1 over 2 to the third y to the 12th. I just put them down at the bottom to make them positive. And then I can actually simplify even 2 to the third even more. So 2 to the third is 8. So my final answer is going to be 1 over 8 y to the 12th. 1 over 8 y to the 12th. Now the last exponent property law that I'm going to teach you is when you are dividing with the same base, when they have the same base. So remember when they had the same base and you were multiplying, you added the exponent. So the inverse of adding would be subtracting, since the inverse of multiplying is division. So obviously you would do the opposite as well to the exponents. So you're going to subtract these when dividing with the same base. So 8 minus 3 is equal to 4 to the 5th power. So this would simplify that, and then you would simplify that and actually write it out. 4 to the 5th power is 1024. So that's my final answer. Now when it gets tricky is when you have more than one exponent property law in, but you got to follow PEMDAS too. Okay, so since this is divided by everything on top, you need to simplify the top and you need to simplify the bottom separately. So let's simplify the top first. This is the exponent property law of multiplication of the same base. That law said that we added the exponents. So 10 plus 20 is 7 over 30. And then down here, we have the exponent property law of a power raised to another power. So remember that law said to multiply the exponents. So 14 times 2 is 7 over 28. And then we have the exponent property law of division where it says to subtract the exponents. So we have 30 minus 28, which is just 7 squared because 30 minus 28 is 2. And then we can simplify that even more. 7 squared is 49. So my final answer here is 49. Another thing that I'm just going to teach you really quickly is if you have 4 to the negative 2 divided by 4 to the 8th. Let's say we have 4 to the 8th. Remember how I said don't simplify the negative exponent until you follow all the exponent property rules if there are any. If there are not any exponent property rules, then go ahead and simplify the negative exponents first. But since there is an exponent property rule here of division where we subtract the exponents, I'm going to do that first. Negative 2 minus 8. So that would be negative 10. So we get 4 to the negative 10. 4 to the negative 10. And then we can simplify the negative exponent where we get 1 over 4 to the 10th because we have to put it in the denominator. Then 4 to the 10 is, so we have 1 over 104, 8576, so that's 1,048,576. So this would, that would be 1 over all of that, 1 over 4 to the 10, okay? So that is exponent property laws and also negative exponents. I'm going to do one bonus problem just so you know it. So we have negative 2a squared b all raised to the third power and ab raised to the third power. In this case, you're going to distribute that exponent to everything within the parentheses. So here, I'm going to distribute that 3 to the negative 2. So it'd be negative 2 to the third power. I'm going to distribute it to that a, so a squared to the third power. And I'm going to distribute it to that b, so b to the third power. So I distributed that 3 to everything in the parentheses. Now I'm going to distribute this 3 to everything in the parentheses. We get a to the third power and b to the third power. Now I'm going to apply the rule, a power raised to another power, and multiply those exponents. So, well, here I have negative 2 to the first to the third, so it's just negative 2 to the third, and I can just go ahead and simplify that. So that would be negative 8, because negative 2 times negative 2 is 4, and then 4 times negative 2 is negative 8. Here, let's simplify it. A to the second to the third, multiply those. 2 times 3 is 6, so a to the 6. And then here, remember, understood as 1, so that would be b to the 1 times 3, which is b to the third. Over here, same, it's understood as b to the a to the first and b to the first. So a to the 1 times 3, it would just be a to the third, and here b to the first, 1 times 3, b cubed. Now I can simplify this because this is all multiplication, and multiplication, if it had the same base, we add the exponents. So I can add all the a exponents, so 6 and 3, which is 9. So we have negative 8, a to the 9th. And then for the b's, we have 3 and 3, which is 6. So b to the 6th. And then I have it simplified.